Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about parameters and wiring of stepper motor. Our lesson will cover the following two main topics. Through this lesson, I hope everyone can identify and explain the main parameters of stepper motors, correctly connect the stepper motor to the driver based on the provided wiring steps, and set the driver's microstepping and motor actions. Stepper motors are widely used in various automation control systems and are key components for achieving precise position and speed control. Proper parameter settings and wiring methods can prevent damage to the motor or safety accidents due to incorrect parameter settings or wiring errors. 1. Main parameters of stepper motor include 1. Phase count refers to the number of coil groups inside the motor, commonly 2-phase, 3-phase, or 5-phase stepper motors. 2. Steps, the number of pulses required to complete one cycle of magnetic field variation or conductive state, or the number of pulses needed for the motor to turn through one tooth pitch angle. 3. Stepping angle, the angular displacement the motor rotor turns corresponding to one pulse signal. A complete 360-degree rotation of a stepper motor equals one stepping angle, typically expressed in degrees. Common step angles include 1.8 degrees, 0.9 degrees, 0.72 degrees, and 0.36 degrees, with 1.8 degrees being the most common. Additionally, the step size refers to the rotation angle driven by a single pulse signal, and the stepping angle is the reciprocal of the step size. For example, step size equals 1 divided by step angle. 4. Holding torque, the torque that locks the rotor by the stator when the stepper motor is powered but not rotating, also known as the locked rotor torque. Holding torque is an important parameter for selecting stepper motors, determining whether the motor can withstand a load and maintain its position. 5. Detent torque, the torque that locks the rotor by the stator when the stepper motor is not powered. There is no unified translation for detent torque in China, so it can be translated as positioning torque. Reactive stepper motors do not have detent torque since their rotors are not made of permanent magnetic materials. 6. Step accuracy, whether the step angle of the stepper motor is accurate, usually expressed as a percentage, such as ±5%. 7. Step angle error, the error between the actual position and the theoretical position after rotating a certain number of steps under no load or loaded conditions, usually provided by the stepper motor manufacturer. 8. Out of step, the number of steps moved by the motor is not equal to the theoretical number of steps during operation. 9. Offset angle, the angle by which the rotor tooth axis deviates from the stator tooth axis. There must be an offset angle during motor operation, and the error caused by this offset cannot be resolved by microstepping. 10. Torque frequency characteristics, the curve showing the relationship between output torque and frequency measured under specific test conditions. 11. Rated current, the current level at which the stepper motor operates under rated conditions, determining the motor's output power and feet generation. 12. Resistance, the resistance of the windings inside the stepper motor, affecting the motor's current sensitivity and losses. 13. Inductance, the inductance of the windings inside the stepper motor, related to the response speed and rotational speed of the motor. 14. Inductance to resistance ratio, the ratio of inductance to resistance, reflecting the motor characteristics of the stepper motor. 2. Wiring of stepper motor. Stepper motors are a common type of motor, and their precise positioning and programmable control features make them widely used in many applications. Correct wiring methods are crucial to ensure the stepper motor operates normally and to avoid damage. 1. Wiring steps. 1. Connect the stepper motor to the driver. Connect the stepper motor to the stepper motor driver. 2. Connect the power supply. Connect a 24 volts DC switch power supply to the stepper motor driver. If the stepper motor also uses a 24 volts DC power supply, it can share the same switch power supply with the driver. 3. Connect control wiring. Connect the positive terminal of the pulse input signal and the direction input signal from the stepper motor driver to the 5 volts terminal of the controller. Connect the negative terminal of the pulse input signal to the Y1 output terminal of the controller. Connect the negative terminal of the direction input signal to the Y2 output terminal of the controller. 4. Set the microstepping of the driver. Generally, it can be set to around 1600. After preliminary debugging, set the actual required microstepping. 5. Set the motor actions. Configure the motor actions, such as forward and reverse, as needed. 2. Wiring methods for different axes of stepper motors. 1. Single-axis stepper motor. Follow the basic wiring steps to connect. 2. Dual-axis and 4-axis stepper motors. The wiring principle is the same as for a single-axis motor, but multiple stepper motor drivers need to be connected, with each driver's wiring done independently. 3. Precautions. 1. Power supply polarity. Ensure the polarity of the power supply is correct to avoid damaging the equipment. 2. Microstepping settings. Set the microstepping of the stepper motor driver according to actual needs. 3. Debugging. After completing the wiring and settings, perform preliminary debugging to ensure the stepper motor operates normally. In this lesson, we learned about the parameters and wiring of stepper motors. The significance of proper wiring lies in ensuring stable operation of the motor and extending its lifespan, while avoiding performance degradation or equipment damage due to wiring errors. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.